Okay, Assalamu alaikum students, and welcome to this program wherein I will teach you how to copy string. So we got the model small. ये मैंने आपको बता चुका हूँ मैं आपको कि models can be tiny, which is actually used for the COM program, and we could have which जिसमें एक ही segment होता है. We could have the small as we have here models, memory model. Actually small it could be which is in which we have at least one data segment and one code segment, and of 1k each, sorry, of 64k each, and there can be many models, but we are using here small. So let's discuss this thing about the program. We have a data segment here. We have the dots. This is the shortcut for the assembler to do things by itself, like those assumes, etc., etc. I know those things. So I go quickly to the without wasting time with the data segment, wherein we have the string one, defined byte means give these much of bytes to the str1. That means these are 1 to 7 characters actually, w to e, so 7 characters. So it's 7 bytes assigned to str1, in which we have w, e, l, c, o, m, e in the 7 bytes. And str2 is again is the defined byte. We have the 7 bytes reserved for str2, and it's a duped zero, means initialize all those 7 bytes zero. So we all zeros in the 7 bytes of the array called str2, and the dollar at the end is requisite when we use when we interrupt 21h key function. What was that? 9h, yeah, 09. And we use the 09h of the interrupt 21 function, which is used to print strings. वो हमें dx रजिस्टर पे और डॉलर के ऊपर काम करते हैं, एंड डॉलर से ही होता है उसमें. तो मैसेज यहाँ पे एक और है कि स्ट्रिंग आपकी सक्सेसफुली कॉपी हो गई है, ended with the, here we got the 10, it's from the new line, and the dollar generate. Yeah, so now it's the code. In the code we've got an initialization point here. Sorry, we've got initialization point like start. It's a label, start label, and then initialization of the registers as well. We have to use at the rate of data to the ax and ax to the ds, because we cannot initialize the segment registers directly, so we have to use indirect method. First this into this ax, then put ax into the ds, whatever. Now I will start the code. What you gotta do, we have to put this welcome into this character wise. First w, then e, then l, then c, then o, then m, then e. So what I do for the w, जो कोड में लिखूंगा w को कॉपी करने के लिए स्ट्रिंग सेकंड में, वही e के लिए लिखना है, वही l के लिए, वही c, और वही लास्ट में सब के लिए. मतलब ये कि जो मैं कोड लिखूंगा w के लिए, वो एक मैं लूप में रखूंगा, which will be run how many times? Yeah, how many? 7 times. Why? Because this is 7 characters. So 7 बार वो लूप चलाऊंगा, और 7 बारी पहले w इसमें कॉपी करूंगा, फिर एक पॉइंटर होगा जो e को पॉइंट करेगा, फिर e जाएगा इसके इसमें, और उसमें एक पॉइंटर होगा जो इसके आगे थोड़ा चलेगा. पहली बाइट में w डालना है, दूसरी बाइट में डालने के लिए e डालना है, तो यहाँ दूसरी बाइट पे चलना है, यहाँ e पे, फिर यहाँ l पे चलना है, यहाँ तीसरी बाइट पे, and so on. So because I have to run a loop, that too for 7 times, that means I have to initialize. First thing I should initialize, which one? Yeah, cs. So I will initialize cx, not code segment, sorry. So it's code, this is the for the counter we use cx. That's how much I will put in 07. Yeah, or 7 you can write, no problem. This means this is to initialize a counter here. So because my loop has to run 7 times. Okay, now then I should have a pointer which will point to the w here, and I should have a pointer which will point to this str2. So I should load the offset of str1 somewhere in some register, which will act as a pointer, and also of this str2, which will act as a pointer here. So I got 2 pointers to declare here. So one I will put in the one register, and second register. We could do it by the, as we have done it earlier, by the offset. We say move some in some register, comma offset of, for example, str1, or we could use a shorter instruction, LEA, sorry, a shorter instruction to do same thing is load effective address into the register. Basically we use SI or DI, source or destination index, with the LEA. So I put in the SI, for example. What else? STR1. This will load the offset of STR1 to the SI. We could do it in a different way also, what we had done earlier. Maybe we do it later on. And also load the effective address in the destination index of STR2. Now I got the 2 pointers, which is one pointing to the STR1, which is actually pointing to the first memory location, W, the first byte of the 7 bytes, and LEA, this one, which is the destination index. Destination index will point to the, what happened? Yes, STR2 is gone here. STR2, I should print again. Actually, why? So DV से हमने जो 7 बाइट्स STR2 को दिए थे, उसकी पहली बाइट को पॉइंट करता है destination index. Okay. Now I got the pointers initialized. Now I have to put what is in this pointer into this, or just into this. But I cannot move from one memory location to the other because these are the memory locations. But I can't move something from one memory location to another memory location. The move doesn't allow memory to memory transfer. So what we have to do is we have to use some register in between, maybe some AL or whatever. And so when I want to transfer data now. So I got the initialization of, I got the pointers initialized here. Maybe I say here pointers are initialized. Pointers are initialized. Okay. And now, what should I do? What should I do? Can you tell me? Are you feeling sleepy? Okay, we should do one thing. We should start transfer. Start transfer of string into what bank? No, into the string second. Yeah, you're very intelligent. So here we go. It is, but how we do? It's a move instruction as well. Move what? In the AL, because I told you I have to use some in-between register. That's the AL. I cannot do memory to memory transfer. So I put first in the AL, what? W. I have to put first W in the AL. Then that AL, the W will be put into the STR2's first byte. Okay. Now move AL. What I will move into the AL? Because this STR1 is located by the SI. The index of STR1 is located by the SI because I have to actually traverse this array, first W, then E, then L, then C. So I put the first address, the offset of STR1, into the SI. Later on I could increment SI as well to go to the E, to go to L, to go to C, and etc, etc. So first thing is I will put what is SI pointing? What is SI pointing? You tell me. SI is pointing to the W, but SI has an address in it. SI locates, SI is a pointer which points to the W. So I have to say what this SI points to, that you put in the AL. What SI points to is that this thing to be written here is like this. Bracket, SI bracket. This means contents of SI. Means don't put SI in the AL because SI has the address of STR1. I don't have to put address in the AL, rather I have to put what lies inside the address. This means this thing, what lies inside the address, put that thing in the AL. Now I got the AL with the W simply because SI was first pointing to the W, so I got W now put into the AL. Now what else I will do with this AL? I will put that into the first byte of STR2, and first byte of STR2 is located by is DI. Because DI has the address of the STR2's first byte. But I don't have to write DI here, I have to write DI like this, brackets, because this will tell me put things into the address specified by DI. Because DI has some address in it. What I'm doing, yeah. Because DI has some address in it, okay or not? So DI has got some address in it, and the brackets tell us that what lie the memory location which points by the DI, put there what? AL, because we have data now in AL. W is in AL, so put that W in the DI. It's simplified. It's actually if simplified, this actually means put W to the first byte of the STR2. It means like this. Okay, probably you understood. If not, then you gotta be dumb. I can't help. Anyways, I assume you understood things. Okay, I can move forward. Anyways, what you got to do now? I got the W here into the STR2's first byte. Now I got to do this thing for E. So I increment this source index, because source index was pointing to W. I increment it so that it points now to E. Similarly, I have to increment DI such that it points to the next memory location. Okay, fine. So what I will do is I will say increment SI, and similarly I will say increment DI. Okay, but one more thing I got to do is, because I have to run this loop for 7 times, so I say, because I will create a label here so that I will tell you transfer run this thing for the 7 times, but I have to decrement CX, because if CX has a 7, next time it should have 6, then 5, 4, 3, 2, 1, 0, and it should not work after the 0. Okay, so I have to decrement CX. So I'm gonna decrement CX. What I'm writing, I should say decrement, DEC. I should use caps, but I'm not using it. It's a very lazy way of doing things. Anyways, I'm sorry for this. Then I have done with the code for the W. Same code will be run for all the things, but I got to jump here. So you got to jump from here onwards. Up to what? Up to this position, isn't it? So I will create here a label. Maybe I will call my, what does people call me? Jenny. Okay. So here we go. I will go to the Jenny here, but I will create a conditional jump. I will say J and Z. This is the conditional jump to Jenny. What is the conditional jump? The jump is not 0. This actually means it has to do with flags as well, but I will make a simplified statement. That is, if CX is not 0, definitely it is not the first time it is 7, it's not 0, jump to Jenny. But if it is 0, sometimes because we are decrementing constantly the CX, this will become 7, and one time it will hit 0 CX, then it will go out the loop. Okay, yeah, so it's like this. So I did this thing because if we see for the first time what will happen, because SI will have the offset of STR1, that it will be here, it will pointing to the W, and this thing what's this, DI will be pointing to the STR2, first byte of the STR2. Then I'm moving the contents of SI, that means W, to the AL, and then AL to the DI. DI is pointing to the first byte of STR2. The STR2's first byte will now have W in it. But I'm incrementing SI then. Here, I'm incrementing SI. So that means SI will point, it was pointing to W, now it will point to E. Similarly, I increment DI, because it was pointing to the first byte, it will point to the second byte, because E will be placed in the second byte. Is it or not? Similarly, because it would be CX will be decremented to become 6. Again, jump, if not 0, the condition will be checked. Is CX 0? No. Then what shall it do? It will jump to Jenny. It will jump to Jenny. That's my name, and I'm gonna teach again. That means this will do the code second time. In the second time, now SI. Now counter SI is this time E, not W. Put E in a AL in a DI. DI means second byte of STR2. increment SI, so that SI now points to AL and DI to third byte. Very good. Then again decrement the CXY, because this will become now 6. Yeah, CX becomes 6, and so on. When it becomes 4, 3, 2, and we'll put EL, C, O, M, and E into it, it would have become, because 7 times already 1, 2, 3, 4, 5, 6, 7 times, because after 7 times, 7 decrements of CX here, it will become 0. And if it becomes 0, I got nothing to put in the string second. So it's time to go out of the loop, because the condition will become false, because a jump if not 0, but it is this time it is 0. So jump not 0 will become false. It will go out of the loop, and when it's out of the loop, what do you got to do? What, you got to take a dinner? No, we got to print it. So printing is done by move AH comma 09H. Is it or not? So printing is going to do with the to move 09H into the AH. It's the function call, but you cannot do it alone. 9H is just a 9 which will put in the AH, but we have to some way to say assembler, hey assembler, this is the function 9H, not the just an ordinary 9 a digit, hexadecimal digit. And but 9H, that means I have to use here interrupt 21. Interrupt 21H. When assembler sees interrupt 21H, at that time AH is chucked. What is an AH? Because interrupt 21 means we are telling assembler that stop it, we gotta do some interrupts. So it chucks the AH. In AH we have 9H. When you see the 9H actually multiplies it by the 4, that is 36, and the 36th location in the interrupt vector table is chucked. We got IVT. It's like an index of a book. If you are wondering what is this IVT, it's like an index of a book. You look for a word, some maybe some word or maybe some chapter. If it's an index, okay, index in the back of a book, you're looking for a word. That word has the page number, and with it, at the index of the book, on the back of the book, we have indexes, and when you see that page number is the address of that actual thing. That means that definition or whatever you're looking for, that word, that actually located on that page number. So actual thing is on a page number, but indexes only store the shortcuts or addresses. Okay, like that, IVT, interrupt vector table, stores the shortcuts or addresses where the actual function is. The function which here I want to print, whatever I want to print, a string or so, that is a function which will print this string to the memory, to the monitor, and that function is written. So obviously we need some code to print that on the monitor. That code is actually written as a function. We call them interrupt service routines, and they are somewhere in the memory. Their address stored in the IVT, and the addressing is done by multiplying this function call 9 by the 4, and at the 36th location in the IVT will be the address of that function, where the actual code is. That code will be called and executed here. Okay, a long story, my god. So I got to do it short. But when we call this 9H function, which is gonna print things on the monitor, that chucks the DX register. That prints only what is in the DX register. So we have to put something in the DX register. Actually it prints from the, and we cannot say in the DX register, it prints from the DX register. From means because we had to point DX register to a certain memory location. From that to the dollar sign, it prints everything what is between that memory location and the dollar. I will tell you in a couple of moments you understand that. So I will again use a load effective address, LEA, but this time around in the DX, comma, of what? Of what I got to print? I got str2 to print. Is it or not? Now look here, because we got in the DX register, rather we should print first message, isn't it? We should print first message that string was successfully copied, is it? So here I will give it the offset of MSG. That is this thing. Give offset of this MSG, into the DX. The 9H will let it print from the memory location pointing DX. DX is pointing this time to S. This is S, the first byte, I can say. The first byte is pointing this DX. Okay, and when you print it from here onwards up to D, that means the dollar sign. The dollar sign is stored. 10 is not stored. Dollar sign is stored on the next byte. The D have the D because with the D at the end. After that, the next byte will be dollar. So this 09H will see the first byte, which is the address of that is stored in the DX, because message has the first address, that is S, that will be stored in the DX, and from DX onwards up to D, because after that the dollar sign. So we have up to dollar sign, can say, but dollar sign will not be printed. That everything will be printed, whatever is in between. Okay, yeah. So our message will be printed. Now we have to print this thing. We have to print our string second. So string second again will be printed in the same way by the 09H. We no need to tell move AH into 09H because AH already has 09H. I will only load effective address into the DX, but this time around what? str second. But I have to call the interrupt 21H. So again, after printing this, when interrupt 21H, this interrupt 21H is seen by the assembler, that sees what is an AH, 09H, and do all the things that long story, and start printing this message. Okay, I told you how. But now, okay, after that, again when this interrupt 21H is seen, okay, it sees what is an AH. H again the 09H is already there. I have done nothing to the AH. I have not updated AH. 09 is already in AH, so not to write here second time. But this time when it sees 09H in the AH, it will see the starting address in the DX, and it is now the str2. So if you look here, it is str2, second starting address str2, this is the first byte. In fact, if we have copied successfully, then in the first byte will have W in it, and up to the dollar, because 7 bytes will have this much of thing. After E here, it will be dollar sign, so it will print from W to dollar. Okay. Yeah, so it's printing. So when it's printing, why don't I print them? I mean, this is already, I told it's end processing, so it's time to run it and print it. So I will say what? Command prompt, where I will say for the first step to assemble TASM, what's the name of the file? It is cop.asm, and when we could have done cop only, it will take ASM itself, but when we assemble this ASM file, ASM is the source file we had, that means this thing, that means this one what we have, but when it assembles it, it makes its object file, so we have to link that, we say t-link, but not cop.asm, rather we should say cop. What else? Obj, object file. Okay, when we are done with the assembling and linking, then we got to execute it, because after this we will have a cop.exe file being made by our assembler, definitely. So we got to run it. We'll say either cop or cop.exe, and our cop, it's a short for copy, by the way. Bang, it's running. String was successfully copied, and that is welcome. So I think you have understood the things probably. And anything more to tell? Nope. So it's to say nope in the assembly. Nope means what? Do nothing. So take care and goodbye.